Yes, welcome to our Vision Plus channel. Once again, I'm taking people through the extraction of alkanes. In the previous subtopics, we talk about the classification of hydrocarbons, and alkanes happen to be one of them. We have alkene and alkynes, but we are going to look specifically at alkanes. So far we have talked about how we can name the different uh, alkanes, how we can give them their names based on the IU pack. Then at the same time, today we're going to look at the extraction of alkanes. So don't forget to subscribe to our channel, Vision Plus. Don't forget to share it with your brothers and sisters who are in senior four in South Sudan. We are following the curriculum of South Sudan. So here we are for organic chemistry. When you say extraction of alkanes, in other words, we're saying removal of alkanes from the natural sources that we are getting them. So we are saying crude oil and biogas, these are just the main sources of alkane. There are other sources, but these one are the main sources of alkane. But also natural gas is found where on top of these crude oils. If, if we are saying this is underground, of course, where these things are, then if this is crude oil from down here, then on top here you get what we call the you get what is called the natural gas. This is how you get the natural gas. It is on top, and that gas is mainly methane. And each being on top can be explained that it has, let's say, one carbon atoms, and it is light. It is light compared to the other fraction of crude oils. So we are saying here, for us to separate the different alkane from crude oils, we have made it possible through the use of fractional distillation. This is just a method of separating mixtures. I think you got this distillation in senior one. So it's just a method of us to separate the mixtures. But here we're going to subject the mixtures to very high temperatures. And at the end of the day, we shall now start separating them based on what? Based on their boiling points. So we are saying this distillation take place where? In the what? In a very tall tower. And we call that one fractional column, or sometimes we call it fractional tower. And is where you can subject your oil, which is the crude oil, still in crude forms, and you get the different fractions. What is happening basically in fractional distillation is that when you subject this oil to very high temperatures, they will first of all go to what we call the fractionating columns. After reaching to the fractionating columns, then they will proceed. Then after proceeding to the top part, what will happen is that those one with the lower boiling points, they will start what? To be like, they will start coming out. If this is your fractional distillations, you start subjecting the heat from here, high temperatures. After subjecting heat, what will happen is that this one will move. And now here, there are different chambers here. So the one with lower boiling points, that boiling point can easily be reached because of the high temperature subjected, and then you get that substance. Until you separate, you get all the fraction. Now, here we are saying that this NB mark it carefully because we are saying the carbon chains increases as we move down. So the down we are talking about in previous lesson, we have seen that we have methane, we have ethane, we have propane, we have butane, and etc going down. So when you move down like this is the chains we're talking about. When you move down, what will happen is that when the carbon chain increases, what will happen is that it increases the what? The boiling point. So why are we saying like, because the molecular masses keep increasing, the molecular mass keep increasing. Like here we have one carbon atom, two carbon atom, three carbon atom, four carbon atom. So what is happening here basically is that the molecular mass has increased, and therefore they require much heat for their boiling point to be what? To be reached. And therefore the viscosity, the heat of flow can also increase. Then the color intensity. Now, when we talk about the color intensity, these things they have different colors. But when you look at them critical, when you keep going down, hmm, the intensity when you look at the color, it keeps changing. It keeps like becoming more deeper compared to those ones which are lighter ahead there. Now here the opposite is with the what flammability. So here again, when we move down these chains, we are saying that flammability decreases. Why are we saying like that? If this is flammability and I'm moving down, so what will happen to it is also what? Decreases. While boiling points, three things are what? Increasing. We have boiling point, we have the viscosity, this is the resistance of leads to flow, viscosity. Then we have the what? The color intensity. So these three here, what will happen is that if I move from up, I'm going down, these three they will keep on what? Increasing. So this one they will increase. Now, what will happen is that the flammability keep on what? Decreasing, because we are saying when I burn methane, the heat energy needed to burn methane is not compared to the what? To the heat energy to burn the what? The ethane gas and also propane up to butane. This can be explained in a way that here we expect the number of carbon atoms to be increasing. So therefore, the molecular mass become high to the extent that you need much energy to be subjected, such that that substance will burn. So when we move down, these three things keep on increasing: boiling points, viscosity, and the color intensity. But also at the same time, flammability decreases. Then we come to something very, very, very important. We talk about the cracking of alkanes. Now, cracking, this is simply you're breaking the long chains of alkane into shorter what? Shorter molecules. And now, when this happens, you are going to produce alkenes. We talk about alkenes. Is one of the classification of what? Of hydrocarbons. We say alkenes have what? Alkenes have double bond. We shall see from the equations. Alkenes, they are double bond between at least two carbons atom. We see double bond between at least two carbons atom. So that one is telling us clearly that when we break these alkanes, we shall get alkenes, and sometimes, not that all the time, but sometimes hydrogen gas is given out in the process. And this take place at elevated temperature. The temperature must be very high, but also there is need for a catalyst. So you are told clearly in senior to that a catalyst is a substance that speeds up the rate of chemical reaction, but it remains unchanged at the end of the reaction. So the moment you don't want to put that word remain unchanged, then that ceases to be what? To be a catalyst. So catalyst will speed up these rates of chemical reactions, but at the end of the day, it will not participate in the products. You will not get it there in the products. So these reactions, when you look at it critically, this is what we call propane. I told you how to name this thing when you look at the previous examples. We say 1, 2, 3. So we have three carbon atoms. We say pro. And when we look here critically, this one is alkane. Why? Because when you open up this, you will see that there are single bonds between the carbon atoms. So this is clearly indicated that we have alkanes, and now we are breaking this one into shorter what? Shorter chains. Heat is here, then a catalyst. Now we shall produce what is called methane gas, of course. Then we shall produce a gas called ethane. We shall talk about ethane ahead, but simply it has the word we shall have two carbons atom. So we shall have two carbons atom, but the word ENE here is indicating that they are what? They are double bonds between at least two carbon atoms. So we shall see in that format. Then now we shall now put our hydrogens. Shall put our hydrogens. We shall put like this. So this is the structural formula of this gas which is being produced. I'm just revising this thing for you. Now hydrogen gas also will be given out. That's why we say it clearly here that when we do cracking, what will happen is that we shall produce alkenes. So this is under alkenes because we are seeing BNE. Then at the same time, hydrogen gas is given out. Now there's this NBI is very, 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 very sensitive here. They say there is higher demands for what? For shorter chain alkanes than what? Than longer chain alkanes because we use most of them in lighting at home, a lot of things. Now, if that's the case, why do we say so? The reason is just very simple. They are used more frequently as compared to the what? To the longer chains. And therefore, because of that, we carry out what? We carry out cracking. Now they will ask you a question. Why do we carry out cracking? It's just very simple. We carry out cracking simply to get the what? The shorter chain alkanes, which use more frequently compared to what? To longer chain alkanes. And for that reason, therefore, I will see you in the next lesson.